Hey everyone, I hope you're doing awesome. So this is Codeforces Review 1. So in this video we are going to discuss my experience of Codeforces around 868. I did this contest and I was able to solve 3 problems in it. It was a decent round. The first 3 problems were really well balanced, and the some people had some issues with D and E problem, but I wasn't able to solve any of them, so I couldn't say much about it. So yeah, so my ranking in this round was around 2300, and I'm having a positive delta, so that's pretty good. So let's move on to the problem discussions part. So the first problem was pretty easy. So it is a characteristics. So I would suggest first to pause the video and read the problem, try to think about a solution, and yeah, do that. I'll discuss this problem later. So yeah, so I think you have read it, and I'll just quick explain it with the help of examples. So basically, in this problem, you are given an array, and you need to construct an array with which can only consist of one or minus one. So they define a property known as a characteristics, which is basically when you take two indices from the array, and you find a product of them of elements at those position, and if it turns out to be one, so the a characteristics of that array increases by one. So you need to construct an array with size n with a characteristics equals to 4, a characteristics equals to k. So let's take this example for understanding, like second last example. So in this example, you need to create an array of size 5 with a characteristics equals to 4. So the solution for this example looks something like this. So if you calculate a characteristics of this example, it will turn out to be 4. Let's do it. So you can observe that the product of positive and negative number can two positive and one positive and one negative number can never be one. So you will always take either both positive or both negative. So in this case, if you take both positive, there are three positive ones. So the answer is going to be like 1, 1, 2, and 3. And like there are two negative ones, so so their contribution will be like 1. So the sum of all the a characteristics will be 4. So it turns out you can solve this test case using this construction. And so else if you can solve it, you need to print yes and the array you came up with, else no. So maybe you can again pause the video and think about a solution, and I'll so let's move on to the discussion part. So you can we'll start with one basic observation. So if you like, the crux of this problem is in just this observation. So if you think properly, you will observe that the sequence of array doesn't matter. So the only thing that matters here is the number of positive ones and the number of negative ones. So the observation here is the arrangement of the array doesn't matter. You can do anything and the answer will still be like, it will hold true, because you can always like multiply two integer and irrespective of their position in the array. So yeah, and another observation is that multiplying one positive and one negative integer like 1 will never help, because it can never be 1. So like after this observation, it is pretty easy to solve this problem. So you can just as the test case are small, you can just traverse through the entire array, like for n size, and like just let's say n is 7, and you need to construct a characteristics equals to 4. So suppose array looks something like this: 2, 3, 4, 5, 6, 7. So you can basically traverse the array and place 1 in the prefix and minus 1 in the suffix, and calculate answer for that arrangement. And if it's equals to 4, so then you can print the answer. Else for if you don't find any a characteristics of any array equals to k, so then the answer is going to be no. So yeah, let's take an example. So this could be one of the arrangement for this problem: 1, 1, 1, like minus 1, and 4, there will be 4 minus 1. Like this will not yield the answer, like but you can see the a characteristics for this array will be like there are 3 ones. So 3 into 4 divided by 2, because the number of like it is nc2, we have 3 ones, so the nc2 will be 3 into 4 by 2, and there are 4 minus 1, so their contribution will be 4 into 5 divided by 2. And you can just brute force, like go through every indices and check for this formula. If it's equals to k, the answer is yes, else answer is no. So let's move on to the implementation part. It is pretty standard. I have inputted the n and k, and this flag represent if there exists an arrangement for which the answer is yes, earlier it is false. And here we are like traversing for every position, and in the prefix we are going to place 1, and in the suffix we are going to place -1, and if they are equals to k, they are equal to k, we like break the loop and print the array. And that's pretty much it about the first problem. Let's move on to the second problem. Like the first problem was pretty easy. I'm not sure why like only 7,000 people were only able to solve it, but yeah, let's move on to the second problem. And as always, you should just go and like pause the video and read the problem and think about a solution. Try to think about a brute force solution and try to optimize it. So I hope you read the problem, and let's just try to understand it quickly. So basically in this problem, it is known as short with step. So in this problem, you're given a permutation with of size n and an integer k. And so the permutation of size n is every number from 1 to n are in the array, but in some permutation. So you need to basically sort the array in ascending order. But the condition here is that you can only swap two integer if their absolute difference is equals to k. So suppose the k here is equals to 2, so you can only swap like 3 and 1 for example, and 4 and 2 for example. So like you have to you can only swap those indices, and you need to sort the array that way. And so there is other part of this problem also, in which if like if like sorting the array using the operation I mentioned before is not possible that way, so you can just you can use this one primary exchange, basically where you can exchange you can swap any two position in the array and try to and again try to sort the array by picking up two indices whose absolute difference is k. So if you are able to so you can there are basically three answers of this problem. So if you are able to sort the array without using any primary exchange, the answer is going to be 0. And if you are if you are not able to sort the array without primary exchange, but you are able to solve it with one, at most one primary exchange, the answer is going to be 1, else the answer is going to be -1. In that case, you are not able to sort the array by doing anything. So yeah, that was the problem statement. The constraint were t is equals like constraint of n were 10 to the power 5. So you can do something like n log n or n. So yeah, so I would suggest again pause the video and think about a solution, and I'll move to the discussion. So it is known as the problem is known as short with step. It was also a decent problem. Like I submitted a wrong attempt in this problem because of one wrong observation. So let's first discuss the observation. Like this problem is pretty standard. So basically, if you observe, you will realize that you can only swap the positions in the array whose module k's are equal. So suppose the array is like 1, 2, 3, 4, 5, 6, 7, 8, 9, and k is equals to 3. So these are indices of the array. So you can only swipe like indices whose module k are equal. So we can swap 1 with 4 and with 7. So we can for mod equals to 0, the set is 1, 4 and 7. Mod equals to 1, sorry. So it turns out you can only swap these positions, and like if we take mod is equals to 2, you can only swap 2, 5 and 8. 2, 5 and 8, and it goes on. So you can basically first traverse the array and check, like let's take this example. No, let's take this example. So you can basically let's take this example. So in this case, the length of the array is 10, and the array is this. So you can basically first traverse the array, and when you are at this position, you want 1 here. So you can first store every element's index in a map, using a map. And like for this example, for this case, like we want to replace 4 with 1, so that 1 will come here and it's going to be its like shorted position. So if you check one, the difference between 1 and 4 is equals to 3, so we can swap them, and like their mod k will is also equal, so you can swap them. So the array will look something like this after one swap: 4, 8, 6, 10, 2, 7, 3, 7. And now we are at the second position, and you want 2 here. So like the position of 2 is 1, 2, 3, 4, 5, 6, 7, 8, 8, and the position of 5 is 2. So 2 mod 3 is also 2, and 8 mod 3, 8 mod 3 is also 2. So you can swap like 5 and 2 also. So the array will look something like this: 9, 4, 8, 6, 10, 5, 3, 7. And this like traversal will go on, and if at the end of this you have a sorted array, so then the answer will be 0, else answer could be minus 1, or answer could be minus 1 in case you are not able to sort it. So the answer, so if you observe further, you will realize that these are the family of indices whose mod is 1. So you can always come up with any arrangement here. So you can come up with 4 1 4 1 7 or 7 4 1, whatever you can do any arrangement here. So you can swap 1 with 4, 1 with 7. You can do anything, but you cannot swap 1 with 2. You can never swap 1 with 5. You can never swap 1 with 8. So by using that primary exchange, basically what you will do is you will exchange the indices of two families, and if you are able to like exchange the indices of two families, and then after using that operation you are able to sort it, then answer will be 1, as the answer is going to be minus 1. So let's just move on to the implementation part. And yeah, this was the implementation. I think I complicated the implementation. You can solve it like some using something easy, but yeah. So basically this is input and k, and this is index map of each number in the array. And yeah, so this is where I'm actually inputting the array and storing the indices. So initially the answer will be 0, and in this case we are in this for loop we are trying to sort the array. And like you do not want to minimize the answer, because like in problem they haven't mentioned anything about minimization, so you can use as many operation basically and sort the array. And yeah, so in this for loop we are trying to sort the array without any special operation. So this is pretty standard stuff. As I mentioned, like for the 0th position, I will need like 1 here, so I will get the position of 1. And if the difference between I and the position of 1 modulo k is 0, then we can swap it. So I'm here manually swapping the numbers, but this is unnecessary. So in a Codeforces problem, you will realize you never do these stuff. You are never you They will never ask you to actually sort the array. I'll actually swap numbers. But yeah, so if you are able to sort like else, so if there are some indices in which cannot sort them, so the answer then could be 1, and we break the for loop. And basically here we are checking if we want to like this second case, when we want to swap two indices which belong to different modular family. So we are checking that here, which is basically like you can calculate the count of indices who are at wrong position, and their counter position is in different family. So you can calculate each that kind of indices, and if they are equals to 2, because you are only allowed to have one operation. So if they are equals to 2, the answer will be 1, as the answer is going to be minus 1. So this was the implementation of the second problem. I hope I did a decent job explaining it. Let's move on to the third problem. So this was a good problem. This was a standard problem, but it is a good problem. Like third, let's move on to the third problem. And yeah, this was also a good problem. So as always, you should just pause the video, read the problem, try to think about a brute force, and like optimize on that brute force. So I hope you read the problem, and let's just try to understand it quickly using examples. So basically in this problem, you're given an array A and you need to construct an array B whose product of all elements of array A and B should be equal, and the size of array should be maximum. And there is also one condition that every element in the array B should be strongly composite. So they define an integer to be strongly composite if the number of composite divisors are more than the number of prime divisors. So that was the problem statement, and let's just take this example. So in this example, you are given the size of the array A is 9, and you need to the array is given like this, and you need to basically construct an array B with maximum size, and the product of both elements in both arrays should be equal. So like in this case, the size of array, the maximum size of array could be 4. So they haven't explained it. Let's take another example for explanation. Let's take fourth example. So in this case, the three indices are 3, 10, and 14. So if you calculate, their product is 3, 10, and 14. So it is 420. So you need to come up with an array whose product is 420. And so if you can come up, you will come up with this array. Like the first index will be 4 and the second will be 104, and their product is 420, and they are both strongly composite. So this is the maximum length of B you can achieve. So that was the problem statement, and you need not to print the array B, you just need its length. So that makes the problem like little easy, but not very easy. You can print the array B as well without too much complication. So that was the explanation of the problem. Like you should again pause the video and try to think about a solution, and I'll move to the solution part. So the name of this problem is let's copy this because we want black color. So see automatically. So the name of this problem was strongly composite. And so basically, if you observe the problem statement, you can see like let's take product of A. So this is the product of every element in the array A. So you need to construct an array B with same product. So if you think you can think that you should do the prime factorization of product A, and let's say product A turns out to be 1080, and so the prime factorization of 1080 is this 2 into 2 into 2 into 3 into 3 into 3 into 5. So this is prime factorization of B, and so now this is product of array A. So now we want to construct an array B with the same product. So you can observe here is that for creating a composite number, strongly composite number, you can construct a strongly composite number using these cases. So two equal prime number, and the second case is 3 prime numbers all unequal. So of course I couldn't prove this, so I had just feeling about it, and I tried some examples, and it always turned that if you multiply two equal prime number, it will result into a strongly composite number. And if you multiply, so there is a mistake here, like 3. If you multiply 3 prime numbers who are all unequal, so it will also yield a strongly composite number. So let's take example. For example, like multiplication of 2 is of course 4, and it's a composite number because prime factorization of 4 is like all the factors of 4 are 2, 4. So the number of composite factors are 1, and the number of prime factor is 1. So this is a strongly composite number. And for another case, Let's multiply 2, 3 and 5. So it is 30. And if you do prime factorization of 30, you will see that it is also a strongly composite number. So you should and we will always take these length only, because we need to maximize the length of array B. So we'll always try to minimize the length of numbers we require to create our composite number for array B. So you can just calculate this product of array, all elements of array A, and do prime factorization of it using sieve of arithmetic. I hope I'm like pronouncing it right, and calculate the answer for it. But it turns out that like each of A element are 10 to the power 7, so you cannot. So the result of them and the length of A is 10 to the power 3. So so the length of A, like the product of A, will be really high. This like this number will be really large. It will overflow if you try to calculate like this. So what you can do here is individually calculate prime factors of each element in A, and compute their result into a map or frequency map, and find answer that way. So let's move on to the implementation part. Implementation was pretty standard, because I used like predefined C functions, like I have them on in my template. So I'll just try to explain them. So basically, in this is a set C function which initialize this array, which basically stores the least prime number, that is factor of I, at sieve I, and we can use this array to do prime factorization of any integer n using this factors function. So this is like the most optimized way to do this, and let's move on to the implementation. So basically, I did pre-calculation for the set sieve, because it will otherwise it will take like high computation. So I pre-calculated it, and here I'm taking input, and yeah. So I'm calculating factor for each A position and storing them in this map. And after the like calculation is done, and I've compiled them like frequency of prime numbers in this map, will calculate the answer. So you can just traverse on every prime number, and the count here stores. So we will like priority like include two equal prime number in our answer, because their length is shorter, and we need to maximize the length of B. So we'll use minimum number of prime numbers to create a composite number. So we'll like priority use the first arrangement to calculate a strongly composite number. And so I'm doing that in stores count here stores the strongly composite number of strongly composite numbers using the first arrangement and so basically you can traverse the array. And for example, here the number of like 2 is 3, so you can take any 2 here. And so I'm doing it by 2. And the like for the first case, then the count for this example, the value of count will be 2, 1 from here, 1 from here, so it will be 2. And I'm calculating the left number of prime numbers in left. So if they are if the number of 2 here is odd, so of course you are going to be left with one unused 2. So I'm storing all of those type of prime numbers in left. And and at last we will take 3 unequal number from them and add it to the count and print the answer. And that's pretty much it about the third problem. It was a good problem, like a lot of people did that problem in the contest. Yeah, it was a decent problem, and I hope I explained it, but I could have explained it better, I think. But this is my first like explanation video, so I'll improve it and try to improve it each day. And yeah, see you.